Hello, my name is Robert Liberati, and this is my PowerPoint presentation for AIT 628. Introduction. Today I'll be presenting the research entitled Why Phishing Still Works, User Strategies for Combating Phishing Attacks. This was conducted and written by Mohammed Al-Sharnubi, Furkan Alaka, and Sonia Chiasson from the School of Computer Science at Carleton University in Ottawa, Canada. I will first read the abstract as it is written in the research. We have conducted a user study to assess whether improved browser security indicators and increased awareness of phishing have led to users' improved ability to protect themselves against such attacks. Participants were shown a series of websites and asked to identify the phishing websites. We use eye tracking to obtain objective, quantitative data on which visual cues draw users' attention as they determine the legitimacy of websites. Our results show that users successfully detected only 53% of phishing websites, even when primed to identify them, and that they generally spend very little time gazing at security indicators compared to website content when making assessments. However, we found that gaze time on browser Chrome elements does not correlate to increased ability to detect phishing. Interestingly, users' general technical proficiency does not correlate with improved detection scores. Methodology Part 1, Participants. Participants were categorized by 4 characteristics, those being age, gender, technical expertise, and familiarity with websites. The 21 participants, 12 female, 9 male, were primarily recruited from Carleton University through posters and email. At the end of the interview, participants were given $15 and a debriefing, which told them how well they performed and explained how they can use browser security cues to protect themselves. Methodology Part 2, Overview. Tests were conducted on a standard Windows XP desktop computer equipped with a Tobii 1750 eye tracker. The eye tracker was used to record the participants' gaze information while viewing the entirety of the website. The only software which the participants used during the session was a web browser maximized full screen. A web-based interface allowed participants to navigate easily between the test websites. Participants were given a total of 24 websites. 10 were legitimate and 14 were phishing websites. The participants were asked to determine whether each website was legitimate or fraudulent and asked to explain how they arrived at their decision. Methodology Part 3, Strategies. Strategy A, Web Content. Some participants judged websites purely based on content, despite glancing at Chrome. Strategy B, Brute Forcing Website Functionality. Some participants tested a number of features on each website. They were actively trying to find glitches and hints that the website was broken. Strategy C, Paying attention to the URL. While many participants reported paying attention to the URL, all of them used the strategy in combination with other strategies. Methodology Part 4, Strategies. Strategy D, Using a search engine. 3 participants used Google to search for the website being tested and compared both the URL page content with the search results. Strategy E, Exclusive reliance on SSL indicators. 2 participants reported that they based their decisions exclusively on SSL indicators. Eye tracking data shows considerable time spent on the web page content as well, so it is unclear whether they subconsciously also influence decisions. Results Part 1. The participants took 87 seconds on average to make a decision whether the website is real or fake, with 48 seconds of that time spent specifically on Chrome content AOIs. The average success rate is 53% for the phishing websites and 79% for the legitimate websites, indicating that participants were relatively poor at detecting fraudulent websites even when primed to look for signs of deception. Participants were confident in their decisions with a mean certainty level of 4.25, regardless of whether they had made the correct choice or not. Results Part 2. On average, participants spent 6% of the time looking at Chrome AOIs, 9% of the time on other Chrome elements, and 85% of the time looking at the web page contents. A positive significant correlation was found between the time participants spent looking at Chrome and their performance scores. A positive correlation was also found between the time specifically spent on Chrome AOIs and the performance scores. This suggests that more time spent in observing Chrome and the Chrome AOIs led to an increased ability to correctly assess the legitimacy of websites. Results Part 3. The eye tracking data shows that 90% of users at least glanced briefly at the lock icon during the session, but it is unclear how many actually consciously noticed its state. The eye tracker recorded 95% of participants looking at the HTTPS identifier. 19% of participants referred to the EV certificate at least once. 71% of participants did not proceed when confronted with the certificate warning when viewing the Carleton Research Survey link. Conclusions. The majority of users relied primarily on the superficial appearance of website content. Existing browser cues remain insufficient to help users protect themselves against phishing. Participants had an average success rate of 53% for identifying phishing websites, essentially the same as if users took a random guess. When making decisions about the legitimacy of websites, participants spent only 6% of the time looking at security indicators in the browser and 85% of the time looking at the contents of the web page. Thank you.